Hi, everyone. Good morning, good afternoon, good evening, wherever you are. Thank you for taking the time to join us. So, scaling databases is one of the most common challenges a growing company faces. In today's session, Bianchi and I will give you an alternative approach that helps you achieve database scale in a much more cost-effective and resource-efficient way. Good morning, good afternoon, good evening. My name is Tanmay Sinha. I lead the product team at ReadySet. We are a database query caching platform. We leverage our caching technology to help our customers scale their databases and database deployments in production. As I said, I lead the product team for ReadySet, and I'm joined with me by Bianchi today, who will be giving you a demo for the product. Without further ado, let's get started. So today on the agenda, we have quite a few things that I want to cover. First of all, it's going over the challenges that we have as we have seen that we see customers face when they try to scale the databases. Now, keep in mind, these challenges, these things are anonymized, but these are coming from real discussions, real conversations that I have had throughout my career, not just here at ReadySet, even before that, when talking to customers using data systems in general. Then we will dive into a little bit of what the common solutions are, what are their limitations, and how ReadySet QueryPilot handles those and helps those address those problems. So the first quote regarding scaling challenges should not be surprising to most. MySQL query was running fine on 100,000 line or rows, but as soon as we hit 2 million plus in the table, the performance just went to expletive, right? I don't want to flag YouTube us for yelling curses here. So what is happening? It's not uncommon to see degradation once you see tables hit a certain number of rows, millions or higher. And even the most basic database operations in those cases become expensive. So it's not a surprise when many SaaS applications find all of a sudden new slow queries because they are starting to see growth. Because once they put things in production, more people start to use it. All of a sudden, you're struggling to figure out, oh, what happened? Everything is slow. And then things like these force you to adjust database schemas midlife, make optimizations on the fly. And lo and behold, because you have such large systems, adjusting schema also becomes a challenge. How about this one? I keep increasing the resources on my EC2 instance, but it is no longer helping with query throughput or performance. It's almost like I'm at a point of diminishing returns. So the reality is that disk I/O, network bandwidth, buffer pool pressure, and contention, all of that rises as you scale up. And that's expected. Now, a few additional things that happen as you grow deployment, the storage and I/O latency impacting the throughput hit the ceiling before even CPU cores are saturated. So you have a lot of demand on disk I/O as the queries are complex and as you see more load getting on the database. And this is not just me saying it. There are several studies, which I'll share that in the link later on, that talk about how database scaling often identify infrastructure issues such as coordination, I/O bottlenecks, and network as the primary pain points when you try to scale these relational database systems. And this is a relatively newer one that I have started to hear, especially the word, but the concept is not too foreign here. We have recently grown to hundreds of customers. This is a good position to be in, right? So I had to add dozens of database nodes. Now I am dealing with this quote unquote DevOps stacks. This is a new word for me. So to keep everything consistent and performant. what does this really mean? It just means that you're adding more servers, you're adding more points of failure, you have more configuration drift, you have to monitor more things, upgrade and troubleshoot. So even small changes to schema that were easy to do when you were just still coding the application, all of a sudden becomes harder. Everything from indexing to partition become harder as your database grows. Before I go to the next slide, this is a question that I asked some of our customers. Like, what is that one thing that keeps you up at night? And unsurprisingly, the answer was the growing Aurora, replace Aurora with Cloud SQL or Azure's MySQL solution or database solutions. That keeps me up at night. And this should not be a big surprise. Because this is the only way you kind of try to handle the scaling, especially if it's hitting you at all of a sudden and you're not prepared. So your solution is to prepare by either over provisioning or manually tuning the size of your cluster, the size of your infrastructure at the time of need. And that, of course, comes at a significant cost, which keeps growing. So how do teams address these scaling challenges? The answer is actually pretty simple. Most of the times it is through read replicas. Well, as I said, most, right? There are other ways. You have traditional caching approaches where you can use in-memory cache to offload certain queries, or you can even go as far as adding distributed database deployments where you are sharding the database and handling it that way, handling the scaling that way. It just so happens that both of those systems require significant amount of investment, significant amount of work to get it up and running. So without a doubt, read replicas remain the most common way, the first way, and even the most obvious way to scale these, because there is a lot of flexibility and control still that remains doing it this way. So assuming the read replicas are the de facto standard when you want to scale your system, let's look at the challenges that I talked about earlier, specific. So starting with the first one, right? Query complexity. So we talked about how when you had 100,000 rows, everything was working fine. Now all of a sudden you're at 2 million and things are starting to sort of remain slow. So what is the issue there? Like, the problem here is that replicas contain the same schema and data set exactly as the primary. So if the query is unoptimized, poorly written, inefficient, it's not going to magically get faster. It's going to be, it's the same query running against the same database, just on another box. So you have freed up your primary, you have moved over to this slightly different machine, which could be small, same size, bigger size, but it's essentially the same run. There's no optimization of the query or anything special that you're doing. There's no update to how you're understanding the query itself. It's just the same run on a different place. What about network? What about the I/O and the network pressure? Well, when you have replicas, this actually gets worse because you're now having to manage a lot more. You're having to manage a lot more systems overall. So as you increase your resources, the throughput only grows linearly in this case. And keep in mind, linear growth in this case isn't really the best, because for each unit of throughput, you're having to have that amount of resource put in. You want something that gives you more throughput for less resource. And in a recent study, replication overhead that across multiple databases, 2 replicas essentially more than double the network traffic. So if God help you, if you're running this in a cross-region environment, your costs will blow up exponentially, having to deal with this much amount of traffic, because it's essentially a copy of your database. And this one is fairly obvious. Like your operational complexity is just more. You have more moving parts. Failover is something that is not as trivial. Picking the right replica is a hard problem. You still have to deal with data loss, inconsistencies. In other words, replica is just another database to maintain. So you're still having to deal with everything that you have to do with the primary. You have to handle here as well. There are many tools and capabilities that have made this easier for deployment, especially on managed database services. So I don't want to not mention them, but the complexity grows. There is a lot more that you have to do if you're trying to achieve the scale, the throughput that you desire. So what if there was a better way? Well, I wouldn't be here if there wasn't a better way, right? So this is the part where I share what we are doing and what we're doing differently to handle these challenges. This is where Ready Set QueryPilot comes in. Specifically for MySQL at this point, we have Ready Set QueryPilot in beta for Postgres. If you're interested, feel free to reach out after this. I'll leave a link. But Ready Set QueryPilot is essentially an automatic query caching, workload optimizing, and tool that looks at your application, the queries that it's sending to your database, automatically identifies the ones that are most relevant for caching and caches them. So next time when you send the query, that query gets intercepted by QueryPilot. QueryPilot knows that it has cached that query and returns it back with the most updated results. How is it different? Because then other caches that are available, because it uses Ready Set behind the scenes. Ready Set, if you know, is able to create caches and function without having the need to manage the TTLs, without having the need to maintain the cache. So once the query is offloaded to Ready Set, specifically by QueryPilot, that query under normal operations will never go back to your primary. That's what QueryPilot does, and we do it without any manual intervention. This is something that once you hook it into your primary or whatever your application you have in front of your database, this will look at multiple KPIs, the frequency, the latency, several different KPIs, and prioritize them given based on those criteria to cache. Now, this is available for MySQL. It is something that you can just drop in. If you have proxy SQL running, it's even easier because it just you just need to set up Ready Set and you're ready to go with QueryPilot. So before I hand it over to Bianchi, just a few ways to look at it. We talked about the scaling challenges at the beginning and how the current traditional sort of replicas address them. But this is a quick summary of how Ready Set is able to overcomes a lot of them as we overcome a lot of those challenges. First of all, query complexity. So as you'll see with read replicas, it's still running the same approach as a database, which is great for a lot of things. But in case of a read-heavy, a high-frequency workload, Ready Set performs just better. So you have some millisecond responses, and it can automatically catch things. Resource consumption, as we talked about in read replicas, it's something that is linear. So per unit of throughput, for 1 unit of throughput, you need to have 1 unit of resources added to it. Whereas with QueryPilot, you can have nonlinear scaling, which means that your cost per QPS or query per second is a lot lower than what would it be without it. And last but certainly not the least, operational overheads. Like you just have more. One Ready Set instance can do a lot more, up to 5-10 times more than a single read replica when it comes to throughput. So your operational complexity just goes down because you're just doing less. You're just having less things to manage with Ready Set. So with that, I am going to hand it over to Bianchi to walk you through a quick demo.
All right. So I hope you guys can hear me. Can you confirm you can hear me, Tanmay? Hello. So I think everyone is hearing me. Thank you, Eric, for confirming. So uh, one thing that is really interesting to observe on what Tami just said is that uh, scaling database is challenging. Most of the time, you need to keep the performance and deliver the information on time. What Ready does is to deliver the information, the data when you want. And in comparison to other products that tries to serve as a cache, Ready does all the behind the scenes work for you. So I would like to start this demo by connecting to the Ready Set interface here. It's worth mentioning that Ready Set supports or implements 100% of the wire protocol of MySQL. If you get your application connect to MySQL and connects to uh, uh, the Ready Set, your application will think that I am connecting to MySQL. Okay, so let's see. One of the things Tammy said is worth mentioning is that Redset does not have any TTL attached to the data. It does not invalidate your caches. Once you create your cache, or once QueryPilot automatically created your caches will not expire. So you don't have peaks on the middle of your operation about cache invalidation. You don't need to uh, uh, set your developers aside to implement a new abstraction layer to something else that does not speak SQL. You can just get ready set in, point your application to it, and start using. And one of the things that I would like to show you first here is that I have a table here which is have some products, right? Let's see this table here. I have one of the products, the ID number one, that's running out of stock. And to show you that Redset can deal with the information you insert on your master database and quickly append this information to the existing caches, let's see how we can do that. I have the explain last statement, uh, which is a command of Redset. And sorry if I can if I can type that. Let's see here. Just and let's statement. Sorry. So this last query, it went to our main database, the upstream database. We can see that, right? At this moment, if I create a cache for select the information, the data where ID 1, the chocolate is running out of stock, and then I would like to create a cache for this guy. So I will create a cache from uh, this query here, which is what QueryPilot does automatically for you. But for showing up, I will create this cache. And if we execute this query again, I can just check this query was executed from the ready set. At this point, to protect your environment, if you have caches created for the most frequent queries or those queries that takes more time to execute, if you have caches for those queries on ready set, you save your database for your selling process, the things that makes money, let's say like that. And imagine that I would like to update my stock. I would do update product, set amount as 100 for the product ID number 1. Okay, this is where I'm going to update the stock, and I will check the cache afterwards. Okay, I'm gonna check oh, it's here. Remember, I am using the cache, and I just update the product, and I am reading from the cache. So that is the thing Reset can delivers to you, because uh, in another situation, in a comparison to other products, at this point you need to invalidate all the data you have on the cache and redo the cache, right? And most of the time the information is not even on the cache. So this is a big differential of Reset in comparison to other products. At this point, what I'm going to do is that uh, just showing to you, let me get back here. We have the cache is created here, right? I create for this query. This is now, I would like to show you a real application that was developed to a company that now they went global, but when they looked for us to solve the problem, they arrived to us saying that, hey, I need to scale my database, because the way I am retrieving the information in real time, maybe this is not the best, right? For QPS, queries per second, we have kind of a six queries, six queries per second, and we have a query latency of more than 100. So the company just said, hey, I need you to help me to scale the performance of this database. What we did was to take a look at this application, how this application was interacting with the database, and how this application was sending queries to the database, right? So after caching the queries of this data being retrieved from the database that feeds the dashboard, we propose a test. So let's have ready set caching the main query feeding this dashboard, so we can see how it goes. What I'm going to do is that on my little machine here, I'm running a laptop. Um, I'm going to click a button, and then I'm going to flip the connection string from the database to ready set. Okay, wow. It seems much better now, but at this point we realized that we needed to implement something that fixed the problem we had right now. What was the problem we had at this point? So it was more expensive to print the information on the screen, then grab the information from the cache. I remember we are executing this query against ready set. So, and then we came up with this refresh rate. So I can refresh the screen after more queries. Now I am refreshing the screen after every query. Now I'm going to refresh the query after 11 queries. After 21 queries, I'm going to refresh the information. Okay, at this point, we have something uh, really good to analyze what we have here. So our query latency that was more than 100 is now under 0. And the QPS for this query, for the amount of queries this application is doing, is, let's say, a little bit more than 27,000. Before, it was about 6. It's a huge difference, right? And then at this point, we put this application uh, to work for this customer, and they really had something in real time. All the dashboard was being fed in real time. This is what I have for you today. I'm gonna back to Tanmay, and Tanmay will finish up with the presentation. Thank you, guys.
Thank you, Bianchi. So hopefully, folks, you saw the demo, and I think it is something that we see very often as Ready Set is able to predictably handle the load that gets put on the system. It is one of the most um, CPU efficient way of handling this. So we are putting a lot more load on the memory and analyzing the queries much more effectively. So there are a few questions that I'm seeing here. I'll go through them here. Eric is asking, so you always have to create cache to cache a query. That's a great question. If you're having to, if you're going directly against our command line ready set interface, yes, you would have to create a cache every time you want to cache a query. But with QueryPilot, this is very different. QueryPilot is automatically identifying the queries that are being sent from your application to the database, and then it will create those caches without you having to manually enter or type anything to do it. With QueryPilot, you can also blacklist queries if there are certain queries that you just don't want to get cached. There are ways for you to adjust that list and edit it whether they get processed or not. Just to follow up your question, since you're asking about the demo, if you can see, if you go to scan, you can go there and get access. You can sign up for the demo and set up a QueryPilot cluster against whatever database you have or application you have and get it going. We also have a brief demo video on YouTube where, when we introduced QueryPilots about a couple of months ago, we did some sample runs. You might be able to want to check that out. That will help as well. Riley is asking, does this work on GCP? Yes, it does. Ready said we have a few different deployment methods. So first is we have a fully managed version that is available only on AWS. So AWS Marketplace, you can go and sign up. It is Ready Set Cloud. You have QueryPilot option available there, and that's what the demo is pointing you to. But we also have the private versions of both QueryPilot and Ready Set that you can run on the infrastructure of your choice, be it GCP, EC2 instance. It's a self-managed version that you can also run on Azure, and even your private data center. So we have customers using this in several different, all of the above in deployment configurations. So that's definitely an option. Julian, we only have a minute left here. Julian, how does this fit into existing observability and monitoring tool? You can hook it up. We have a port that can read. Bianchi, do you want to take this one just to give folks an idea of how to hook it up to maybe their Prometheus and
Sure. When you start the service, the Ready Set service, all the metrics will be available at the specific port, which is 6034, and then you can just have Prometheus grabbing those metrics, and then you can use Grafana or something alike. Also, we have a tool for observability on our cloud, readyset.cloud. You can go and test. You can observe everything from the cloud. So you have these options. But natively, ReadySet exposes all the metrics on the 6034 port after going up.
Awesome. Thanks, Bianchi. We're right at time. We have a question from Eric. Does this support MariaDB? Not right now, but we are looking at adding those support. So if you're interested, please reach out. We're definitely exploring how we can bring this to MariaDB as well. So happy to talk more after this. All right. Thanks, everyone. In the interest of time, we'll close the session. Appreciate you all joining. Thank you.